Hi there! Another week has begun, and we are on the cusp of turning the page to another chapter of our discussion of the real numbers. Many of you have found the discussion last week, especially the second half, to be a bit too abstract for your comfort. If you find yourself with that opinion, do not despair. Starting this week, the course becomes a lot more concrete, with lots of hands on examples that are easier to grasp. This is in no small part due to the change of emphasis of this course. Up through last week, we were in reduction land. We were trying to answer the question, what makes the real numbers tick? From today on, we will be proceeding more deductively. We will start from the axiomatic properties of the real numbers and develop many of the concepts you have seen already in calculus, but this time with full justification. The question of what are the real numbers is a natural choke point in this course. Eric Temple-Bell once said, Euclid taught me that without assumptions there is no proof. Therefore, in any argument, examine the assumptions. In calculus, we often use numbers as if we understood what they are. One of the goals of the previous 2 weeks was to get you to question that belief, to ask yourself whether you know what the real numbers and whether you feel comfortable describing their properties. For integers, or rationals, or fractions, the answers to the same question should come fairly easily. Hopefully, from the discussion last week, you began to see that there is some subtlety when asking the same question of the reals. What we did by the end of last week was to describe the quintessential properties of the real numbers. Going forward in this course, when we talk about the real numbers, we will only assume those quintessential properties. This way, we can rest everything we develop going forward on a firm foundation. The goal this week, however, is to eventually reconnect our development of the properties of the real numbers to our prior knowledge of what real numbers look like. So, what are the quintessential properties of the real numbers? First, we can do the usual 4-function arithmetic operations on them. That is, addition, subtraction, multiplication, and division. Second, we can compare any two real numbers and get the usual trichotomy. Either x is less than y, bigger than y, or equal to y. And exactly one of the three is true. Third, the arithmetic operations play nice with the ordering. Fourth, and this is the only one of the properties that distinguishes the real numbers from the more simplistic rational numbers, is that the real numbers possess the least upper bound property. This is the manifestation of the order completeness of the real numbers. If you don't remember what the least upper bound property says, please pause this video and review lectures 3 and 5 of week 2. As we will be using this property a lot this week and next, it is important that you know what it says. If you found last week too abstract and hard to follow, the good news is that since we are changing gears from reduction to deduction, everything from this lecture on will only depend on these 4 properties of the real numbers. However, starting from the next lecture, the topics of subsequent lectures will be tightly interlaced, and you won't get another chance to reboot your learning in this semester. Before stuff got technical last week, we talked about maximum and minimum, and upper bounds and lower bounds. This week, we will start by talking about supremum and infimum. They are just another name for the least upper bound and the greatest lower bound. As the least upper bound property is one of the quintessential features of the real numbers that we identified, you probably expect that the supremum and the infimum will be important for this course. They take a central role in a lot of the constructions we'll be talking about concerning sequences and limits, and so it is crucial to understand these two concepts. And so, we will devote the vast majority of this week in making sure you have a good grasp of what these two concepts mean. The remainder of this week we will spend talking about some other applications of the least upper bound property. These applications will furnish us with better mental pictures of how the real numbers behave. Alright, that's it for the overview. See you in lecture 1.